While we were discussing the law of sines, one of the consequences of the law of sines is that we came up with a new area formula for triangles that didn't require the altitude of the triangle. So let me remind you what we had written. It's actually three formulas depending on the information you have. First of all, to avoid confusion, instead of using the letter A for area, I'm going to use the letter K, because remember when we drew this triangle, we had angle A was capital A, angle B was capital B, and angle C was capital C. And then the opposite sides were lowercase b, lowercase c, and lowercase a. So I don't really want to use letter A for area. So for us, we're going to use the letter K, and K for us means area. And we had three versions of this formula depending on what information we were given. So one version is K, the area, equals 1/2 BC, so 1/2 times leg B times leg C, times the sine of angle A. Another version was the area K equals 1/2 times A times C, sine of angle B. And then the third version was K equals 1/2 AB, and then it was sine of angle C. So notice, whichever two legs you have, it's the other angle. So when I have legs A and B, I want the angle C. When I have legs A and C, I want the angle B. And of course, when I have B and C, I want the angle A. So those are the formulas. Those are a consequence of the law of sines, and what we want to do is practice using those. So let's look at a couple examples. So here's a triangle, and we're given some pieces of information. I really just need to label this to see what I have, and then I can decide what formula to use. So across from angle A, this 14, that's actually side A, and across from angle C, this 10 is actually side C. And then you can see that we're given angle B here. So this is a perfect opportunity to use one of our equations for area to compute the area. So remember, I'm using the letter K to stand for area, just to avoid confusion with this capital A here. So in this case, the area K is going to be 1/2. I'll use A and C and then the sine of B. So we're going to use this formula, A times C times the sine of B. I'll write it out here first. And then let's put the numbers in. So this is really going to be 1/2 times 14, which is A, times 10, which is B, times the sine of 66 degrees. And all I have to do is type that in on my calculator, and I'll have the area of this triangle. So I'm going to do that right now. And when I do that, I get a decimal number here. I'm going to round it off. I came out to like 63.948. I'm going to round that off to 63.9 for the area. And that is in meters squared because our units are meters. So 63.9 meters squared for the area. Don't forget that K just means area. It's just a letter we're using so that we don't have to use capital A. So that one was pretty quick. If you have two sides in the included angle, you can simply crank out the formula and it's no big deal. It's not always that easy though, depending on the information that you're given. Take a look at this next example. So here's another example. This one's more complicated. You can see we're given angle C, which is fine, but the problem is that this is side C and this is side B. So what I really need is this A that's in between C and B. And I think that's going to be the easiest measurement for me to go for. To get there, I got to be clever because I have absolutely no information about side A. So to get to angle A, I'm actually going to get angle B first and then just add them up to 180. So we're going to need to use the law of sines to get angle B so that we can get angle A and then we can do the area. See, this one's crazy. It's complicated, but we can do it. I hope you'll agree that the sine of B, sine of angle B over side B, which is 6, equals the sine of angle C, which is sine of 64 degrees, over side B, which is 15. And we can solve this pretty quickly by multiplying both sides by 6. Those 6's will cancel. And I'll find out that the sine of b is whatever sine 64 times 6 divided by 15 is. Crank it out on my calculator, and here's what I get. That comes out to 0.3595. I'll round it off to 4 decimals like I did before. And then remember, we have to use an inverse trig function to figure out what angle B is, right? To solve for B, we use inverse functions. In this case, on our calculator, we're going to use that inverse sine key like we did in a previous video. And if you type this in on your calculator, inverse sine of 0.3595, you'll find out what the degrees are for angle B. So when I do that, I get B to be about 21.1 degrees. And that means to get letter A, I would just do 180 minus 64 minus 21.1. You can crank that out on your calculator, and you get 94.9 degrees for letter A. So this is 94.9 degrees. All right, we did all that just so we could use our silly area formula. Remember that we're going to do K for area equals 1/2. This time we need the formula with the B and the C. So we're going to do BC sine of A. That's the formula we're going to use from the first slide. When we put the numbers in, we get 1/2 times 6 for B times 15 for C, and then the sine is going to be of 94.9 degrees. And we'll crank that out on the calculator, and that is approximately 44.8, and that is square centimeters. Okay, so just realize that these problems get complicated when the information isn't provided exactly the way it matches up with the formula. What we really need are 2 sides in the included angle, and when you don't get that, you have to use the law of sines or some other technique for figuring out the information you need, like we did here, before we could actually go and do the area, which is what we've calculated here. I've got one more example, and then we'll let you go. In this triangle, again, we're trying to find the area of the triangle, but to do that, we need 2 sides and the angle in between them, and right now we don't have that. So we're going to have to find either side B or side C. And I'm not really, oops, that's not side C, that's side A. I actually know side C, right? So I'm looking for A. This guy right here is C. So C is 5, angle A is 82, and angle C is 64. We're going to need to either get, we're going to need side B, essentially, right? Or we need, if we get side A, we'll need angle B. So we need both the B's first. Long story short. So we can get angle B quickly, right? Angle B is just going to be 180 minus 82 minus 64. And I think through a quick calculation, you'll agree that that equals 34 degrees. So we've got angle B. Now you just have to decide if you want to get side A or side B. Let's just go for side A, and then we'll use the 2 calculations, the 34 degrees and the side A, to get this. So to get side A, we're going to do the sine of angle A, which is 82 degrees, over letter A, equals the sine of 64 degrees, because that's the angle that I have, side C, or angle C, over side C, which is 5. I'm going to do the switcheroo on this, so that I have A over sine of 82 equals 5 over sine of 64. And then to solve this, we simply multiply both sides by the sine of 82, like we did in another video. So these guys cancel out, and I'll get sine of 82 over here. And if I do this math on my calculator, I'll know what leg A is, or side A. That's going to be approximately 5.5 meters. I rounded it off to 5.5. So letter A here is 5.5 meters. And now we can do our area formula, and I'll just use these three measurements here. So the formula that I'm going to use, remember K stands for area in this case, is 1/2 times side A times side C times the sine of angle B. Whatever these two letters are, you need the other angle. So the calculation is going to be 1/2 times 5.5 times 5 times the sine of 34 degrees. And we just crank that out on our calculator. And that is approximately equal to 7.688, which I'm going to round off to 7.7 square meters. So the area of this triangle, after a lot of work, right, we had to get angle B and we had to get side A. But after doing that, we were able to plug this information into the formula and come up with an area of 7.7 meters squared. So you've seen three examples. The first example was pretty much set up so that you could plug it right into the formula. And then on these last two examples, we had to use the law of sines, to fill in the information that was missing before we could use the area formula. And those are the challenging examples. So good luck working on these. If you get stuck, feel free to ask me questions. You know where to find me. Take care.